Okay, so now it's clear, right? So in this
Yes, sir.
session, we will discuss eigenvalues and eigenvectors of matrix, 2 by 2 matrix. Okay, so one important question is find eigenvalues and eigenvectors of this matrix 0 of 0, 0, 0, 0. So solution. So first of all, we will find out eigenvalues and eigenvector. So let A equal to this matrix 0, 0, 0, 0. So tell me what is characteristic equation. A is, what is shortcut method? Lambda square.
Minus trace into lambda plus
Lambda. What is trace here? So trace of A into lambda plus determinant of A is equal to 0. So which implies lambda square. What is trace here? Trace is sum of
0.
diagonal end. 0. 0 plus 0, 0. 0 lambda plus, what is determinant? Determinant of 0 matrix is
0.
0. Is equal to 0. Which implies lambda square is equal to 0. So what are the eigenvalues? Lambda is equal to, how many eigenvalues are there for of A? Lambda is equal to, how many eigenvalues for a 2 by 2 matrix? For 2 by 2
2.
matrix there must be 2 eigenvalues. So what are those eigenvalues?
Lambda is equal to 0.
0, and the next eigenvalue is also 0. So here eigenvalues repeat twice. Now we will find out eigenvector. So this is very important step. So eigenvector corresponding to corresponding corresponding to lambda is equal to 0. So our matrix A is 0, 0, 0, 0. Okay. So how to find out A minus 0 I into x1 x2 is equal to 0, 0. So it implies, what is A minus 0 I? 0 I is equal to 0, 0,
0.
0, 0, 0 matrix itself. So A minus 0 I is the matrix 0 matrix, right? Any doubt? 0 minus 0. 0, 0, 0, 0. x1, x2, 0, 0. So now you find out what is the augmented matrix. What is augmented matrix? Augmented matrix. A minus 0 I. Tell me what is augmented matrix.
0, 0, 0.
0, 0, 0, 0, 0, 0. Tell me, is it in a row echelon form? So how to check whether it is in row echelon form? We will check for the pivot. There is any pivot in the first. What is first element? It's 0. So now we will check the element below that element in the same column. That is also 0. Now we will check the second element in the first row. So that is also 0. And we will check the element below that element in the first, in that column. So all there is no pivot here, and therefore it is in row echelon form. Now tell me, what is this equation? We will get 0 x1 plus 0 x2 is equal to 0, and the above equation is also same. So what you can tell about eigenvectors? There is no condition for x1 and x2. So x1 and x2 are free variables here. Here x1 and x2 are free variables. Have you got it? So we can choose any values for x1 and x2, right? There is no condition for x1 and x2. So how many free variables are there? Number of free variables equal to 2. So we can find two linearly independent eigenvectors. So what I will do is x1 is equal to, I will put small x1 is equal to 0 and x2 equal to 1. I will get an eigenvector because x1 and x2 are two free variable. We can choose any values. So 0, 1. So this is linearly, this is an eigenvector for eigenvalue 0, and there is I, I will find this the second eigenvector. X1 is capital X1 is first eigenvector and second. So can you tell me another free eigenvector? You can choose any value.
1 0.
1 0, so that these two are become linearly independent. So therefore eigenvectors corresponding to lambda is equal to 0 are 0 1 1 0. So you can choose any values. Okay, these are two eigenvectors. So why it has two linearly independent eigenvector? Because we get two free variables. If you have two free variables, you can find two linearly independent eigenvector. If there is only one free variable, you can only find one linearly independent eigenvector. So have you got it? Any doubt? Anybody have any doubt? You can ask me. Anybody have any doubt?
Sir, please,
Yeah, tell me.
uh, what is the basic difference between the raw echelon form and augmented matrix, sir?
Okay, this is first of all, we have to write it augmented matrix, right? So augmented matrix means if you have a metric, sorry, linear system Ax equal to B, then augmented matrix AB is actually is in the form. You will write A here. You just write a draw, and you write B. For example, if you have a system like this 1 2 0 2 x1 x2 is equal to 1 2, then we can write augmented matrix AB is of the form 1 2 0 2. Then you write down this 1. Now then after finding the augmented matrix, you have to convert it into raw echelon form. So what we how to convert raw echelon form? You have to find out the pivot and make the row column below that pivot is equal to 0, and
Zero.
then you already studied how to find out the quotient. So the
Yes, sir.
step is you have to write down the augmented matrix, and then you find out the raw echelon form.
Mm,
So but
Yes.
here this augmented matrix itself in the raw echelon form, because all elements are 0. There is no pivot. Okay. So now we will do another problem.
Sir,
Okay, tell me.
sir, can we write the eigenvectors as 1, 2, something like
Eigenvectors. Okay, so here x1 and x2 are free variable. So you can write another eigenvector as x1. I am taking x1 is 1, x2 is 2. So this is again an eigenvector, and I'm taking this like you can take like 3, 1. So these are also two eigenvectors of 0 because these are free variable, right? These both are linearly independent. And
Okay, sir.
okay, if you take x1 equal to 1, 1, okay, and x2 is equal to 2, 2, these two are also eigenvectors but not linearly independent. Have you got it? Because these two are also eigenvectors of 0, but these are not linearly independent because one is the multiple of other. So what we have to do is we have to choose free variables in such a way that the eigenvectors must be linearly independent. Okay? So if you have two free variables, you can choose eigenvectors in such a way that there are two linearly independent eigenvectors. So now we will do. Any doubt?
No, sir.
So now we will do this problem. Find eigenvalues and eigenvectors of and eigenvalues and eigenvectors of, and tell me 0 a equal to 0 1 0 0. So now you find, tell me what is characteristic equation. Lambda square, tell me,
Lambda square equals 0.
is equal to 0 because trace is 0 is and determinant is 0. So what are the eigenvalues? Eigenvalues are lambda is
0.
equal to 0 and the other eigenvalue is also 0. Right? So the two eigenvalues are 0. Now we will find eigenvector corresponding to eigenvalue lambda is equal to 0. So what is A? So what is that? A eigenvalue is 0. A minus 0 I into x is equal to 0. So what is A here? A minus 0 I means it's A itself, right? So what is that matrix?
0, 1, 0, 0.
1 0 0. And this is 2 by 2 matrix. Then I am writing x1 x2. X capital X is the vector sum x1 x2. Now what is augmented matrix? A minus 0 I. This is augmented matrix. Tell me what is augmented matrix? 0 1
2,
0. Then second row
0, 0, 0.
0 0 0. Now you check whether it is in row echelon form. So what we have to do? First you check what is the first element. This is 0. So if it is 0, then we will check what is the element below that column. That below of that element in the same column. That is also 0. So there we cannot interchange, right? So then both are 0. Then we will check what is the next element in the first row. So that is 1. So we can take this as pivot, right? Now if you get that pivot, then you have to check whether what is the element below that. So this is already in 0. Now is there any pivot in second row? No.
No.
So this is already in row echelon form, right? Echelon. So tell me now we will write. So what is the last row? Last row is 0 x1 plus 0 x2 is equal to 0, and this row 0 x1 plus 1
X2 is
x2 is equal to 0, which implies what you get x2. What is the value of x2?
0.
So x2 is fixed, right? 0. What about x1? Is there any information about x1?
Any arbitrary value.
Yes. So x1 is a free variable, right? So how many free variable is there? So how many free variable? Only one free variable. Free variable. So there, if there is only one free variable, how many linearly independent eigenvectors we have? There are eigenvectors. If there is only one free variable, we can only find one linearly independent eigenvector, right? So, so what is that eigenvector? X1 is equal to eigenvector corresponding to lambda is equal to 0 is x2 is fixed, right? 0. Now what is x1? You give any value.
1.
1. So this is a non-zero eigenvector. Therefore, eigenvector corresponding to lambda is equal to 0 is 1 0. So there is only one eigenvector, and how many eigenvalues are there? Lambda equal to 0 repeats twice, right? So two eigenvalues 0 0, and corresponding to, there is only one linearly independent eigenvector. But for zero matrix there are two linearly independent eigenvectors. Why? Because for zero matrix there are two free variables. Here there is only one free variable. Okay, have you got it? You know, any doubt? So we can do 3 by 3 matrix eigenvalues and eigenvector of 3 by 3 matrix to mark. So we will do one more problem. Okay. So any doubt? Any doubt?
Sir, if two eigenvalues are there, then there should be two eigenvectors, right?
N- No, no, no. If there is two eigenvalues, and if there are two distinct eigenvalues, then there must have two eigenvectors. Okay. If the eigenvalues are not distinct, for example, in this case, in this, in for this matrix, there are two eigenvalues, right? Lambda equal to 0 0. 0 is repeated twice, but while doing we have only one free variable, so we will get only one linearly independent eigenvector. If you choose any eigenvector, so you can choose any eigenvector, because like instead of 1 you can put 2 2 0, but these are not linearly independent, right? Because this is a multiple of this. So if you have repeated eigenvalues, there may have one. If you have two repeated eigenvalues, there may or may not have two eigenvectors. There must may have one eigenvector or two eigenvectors. That is, in this first example, the eigenvalues, there are two eigenvalues 0 0, but we get two eigenvectors, right? But for second example, there is two in there is two eigenvalues 0 0, but we have only get one free variable. Therefore there is only one linearly independent eigenvector. Have you got it? Is it clear? So it's not necessary that we must have two linearly independent eigenvector. Have you got
So
it?
what about the 0, 0 and 1, 0
0 0
eigenvectors? They will
0
be independent, right?
0, 0. For the second matrix, 0, 0 and 0. But tell me, what are the eigenvectors?
1 0 and 0 0.
1, 0 and no. You cannot take 0, 0. Right? 0, 0 is not an eigenvector. I already discussed it. Because 0, 0 we will not take as an eigenvector. X equal to 0 is not an eigenvector. Okay?
Okay, sir.
Sir, what about 3040?
3, 0, sorry, 3,
40.
0,
40.
4, 4, 0. These are linearly um, dependent, right? Have you got it? These are linearly dependent because uh, 4, 0 is equal to, you can write 3, 4 by 3 times 3, 0. So this is a multiple of 3, 0. 4, 0 is a multiple of 3, 0. So these are linearly dependent. Have you got it?
Okay, sir.
So if there is only one free variable, you can only find one linearly independent eigenvector. Is it clear? It's very important. That's why I am explaining this. Have you got it? Is it clear?
Yes, sir.
Okay, good. So now you do this problem and tell me the is it okay? So you note it down these problems. Fourth one, and the sixth one, and to do this problem. And the roll number 12 and 22 post these answers in our WhatsApp group. Do these two problems. Everyone should do these two problems. And roll number 12 and 22 should uh, upload answers in our WhatsApp group, C1B WhatsApp. Okay. Have you got it?